Yeah. Electromagnetic wave is traveling in a positive x direction. So he given here electric field vector. So magnitude of electric field will be this is amplitude of electric field. And what is the value of B? So E naught and B naught are related by an equation. So we must be careful here. If it is in air or vacuum, 3 into 10 power 8. So better we compare given equation with E naught sine omega t minus kx, and that C here is 2 pi anyhow common. So this is 3 into 10 power 8. So velocity of light only. B naught will be so 3.2 into 10 power minus 8 Tesla. It is 10 volts. So current is passing through the circuit. Since these resistors are parallel, so current will be distributed. Since resistances are equal, I1 is to I2 is, in fact, R2 is to R1 once they are connected. So here current will be distributed equally, and effective resistance when they are connected in parallel R here is 2 ohms. Here this 2 ohms, here 2 ohms, and here 1 ohm. They are in series. So effective resistance will be 5 ohms. The current which passes to the circuit 2 amperes. Here 2 amperes current passes through it. And how current is distributed? So current is distributed in 1:1 ratio. That means current through 4 ohm resistor is 1 ampere, equally distributed. Here ammeter reads 0.9 amperes. That means maybe here I1 current, I2 current, I3 current. So all leaves through this junction, that is which is 0.3. He given current through 20 ohm resistor as 0.3. The potential difference across AB is 6 volts. So here potential difference across CD is because they are connected in parallel. So how much current it passes means I3 into 15. That is 6 by 15 amperes. That is 2 by 3 amperes. So here and here it is 20 into 0.3. 15 into I3 is 6. It is 0.4 amperes. So I1 plus I2 plus I3 is I2 is 0.3, I3 is 0.4. I1 will be 0.2 amperes. So potential difference across AF also 6 volts, which is I3 into R, sorry, I1 into R. I1 here is 0.2 into R. R will be 30 ohms. Flux linked through surface area, formula E dot A. So area vector means you said through YZ plane. For YZ plane, perpendicular will be along x-axis. So area will be, area vector is perpendicular to the plane. Flux will be 6I plus 7J plus 8K dot 30I. 180 volt per meter. Here percentage error in Q, log of A power 4 plus log B cube minus log C square. Right. So maximum error in Q will be, even though negative is there, we calculate error, maximum error. That is 3 delta B by B into 100 plus error here, we can see here negative also there. So maximum error only we calculate. We given error in A is 3%. Error in C is 5%. So 34% error. So here, the distance between real object and virtual image is 15 centimeter. So here we have two types of mirrors, curved mirrors. One is concave, other is convex. So virtual image is possible both, but magnified image is possible only in concave. Where it is the principal axis. An object is placed between O and F, focus, pole and focus. Then you have this ray, if you extend it, you will have a visual. This is CD is image of AB. So magnification is height of image by height of object. So that is 2. Height of image by height of object is 2. Height of image is 2 times h naught, which is minus V by U. That means from here V will be minus V. But here U is, we will consider minus U. So here it is plus V. So we'll write like this. What else he given is distance between object and image. That is which is given as 15 centimeters. I took modulus because it is a distance. Mod is 5. But here rays are coming like this. Distances we will measure from the pole opposite to the direction of propagation of light. We'll consider U as minus 5. So focal length so we will be here, it is 10. Focal length is minus 10. Here it is. When rod is moving in a magnetic field, the problem is related to motional EMF. So length, velocity, and magnetic field are mutually perpendicular. Force act on that will be QV. Here it is QVB. So here it is so what we know is potential difference across the ends E into L, that is E, here is VBL. Here V stands for velocity, this is potential difference. 10 magnetic field, length is 5. So here it is 300 into 10 power minus 6 or 3 millivolts. Here, so potential at this point A is 9 volts. Potential it is connected to the earth. Potential difference 0 volts. So shorted means when they are connected. So this problems every time he is giving, and we have to solve problem with respect to steady state. Steady state, no current flow through the capacitors. Then here current flows like this. Again, it's a steady state, current will not flow. Like this current flows. So here 6 and 3 are in series, right? So between 9 and this is 6 ohm, 3 ohm, here it is 0 volt. Potential difference is this. So V is 1 volt. Here So let me write this as E and F. Already AB are there. VE, VF. So here we got potential difference as 9I. I here is 1 ampere current flows through this. Then to find charge on this capacitor 6 microfarad, so we should know what is the potential difference across these 2 points. Here anyhow 9 volts because current is not flowing through this. So let me write this as yes. Vs minus Va will be, so I into 6, that is 6 into 1. So the potential difference across these 2 points is 6 volts. Even potential difference across LB also 6 volts. So then he's asking charge on capacitor. To here is CV 6 microfarads, that is 36 microcoulombs. Here a bob of mass 900 grams is connected to a string of length 1 meter, moves in a vertical circular path. Find the tension at the lowest point. Once it is moving in a circular path, so net force is nothing but centripetal force. With this radius it moves. V is R omega. So tension at this lowest point, mg plus mr omega square. What is the need of omega? He told it moves with a 10 revolution. 1 revolution means it covers 2 pi radians. 1 minute means 60 seconds. That is, so omega here is pi by 30 radian per second. So mass here is 900 grams. Everything answer in newtons. So convert in kgs. So 9 by 10 kg, 0.9 kg. So tension here is 0.9, G is 10. Radius is nothing but 1. Omega square is pi square by 900. So here it is pi square roughly 10, or even you take as 9.8, G as 9.8. So 9.8, you can take common, 0.9 also. You can take common 1 plus is 2 pi revolutions, 60 minutes. Right. It's 10 revolutions, 10 into. So here 10, it becomes pi by 3. And here it is pi square by 9. 9.9 into 10 by 9, 0.1 into 10. So with constant power, so energy incident per unit time. If one photon is incident, so the energy incident on is this, we don't know. With one wavelength in unit time, with he said constant power, equating power, so Hc get cancelled, lambda 1 by lambda 2. So both are in nanometers. So ratio of number of photons emitted is 3:5. So this is energy related one photon. If N1 photons are released, how much energy is released? Here, input signal is sent along NOT gate. This input signal is converted to A complement. Here it is A. Here it is. So this combination is sent along AND gate. Output will be. Here it is B. This is A dot B. Here you have A dot B. Here A bar dot B bar. It is OR gate. The final Boolean expression. It is A plus A bar. So A plus A bar is 1. So that means here input signal, it's okay, but 1, 0. Whatever input signal you are giving, output also, same thing you are getting. So here B is 0, 0, 1, 1, 0, 0, 1. So third option is